Well, thanks for the opportunity to speak today. My name is Jonathan Yu. I'm part of the Environmental Informatics Group here at CSIRO, based in Melbourne. We work at the intersection of data, information systems, and environmental domain science. That could be anything from coastal modeling, hydrology, bushfires, biodiversity modeling, and others. But what my team does is to partner with research teams to develop socio-technical systems, and we've got a history of information modeling, vocabulary development, and systems implementation, as well as metadata. So, quite a long history in that space, and I've also had a history in thinking about provenance systems. Some of this work was inspired or informed by previous work done in the bioregional assessments. And at the time, Nick Carr, Matt Stenson, and others developed a system called PROMS and DIDS, and that's influenced our development here in PROVENA. But I'll just and today I'll be talking about how PROVENA is a solution to enable data provenance for modeling and simulation projects, and we take sort of an applied view on this and share some insights about partnering with research teams in doing that. This work is developed through the Reef Restoration and Adaptation Program, supported by the Australian government and the Great Barrier Reef Foundation. And also we're working in the space of national bushfires, in the National Bushfire Intelligence capability, and that's funded by the Australian Climate Service and the Commonwealth Government. So just acknowledgements to those funding sources in this work. So we want to also acknowledge the PROVENA team, and we've had a rotating list of people work on this project over the last 3, 4, 5 years. And yeah, myself, Peter Baker, Linda, Sharon, Peter Fitch, Fareed, Jordan, Ross, we're current members of the team, actively working on this project right now. But in previous years, we've had others, David Lemon, Sinu, Omid, Simon Cox, and Mark Baird, who's now a research director in CSIRO, be part of this project in its analysis and design and early implementations. My talk's going to be covering these 4 things. So why do we need data provenance? And I'll motivate that through the 2 modeling projects that I've just mentioned. And it's through these projects that we've been working iteratively to develop our ideas and test them out in practice. We will also talk about a sort of general view of data provenance challenges, and offer perhaps a general solution architecture. And then talk about PROVENA as one solution, not saying it's the solution, but it's a solution in this space, which we have applied in those case study projects. And then lastly, just offer some reflections and learnings. Okay, so I'm not sure how often you guys have been in this position where you've come across a data set at that blue cylinder on the left there and wondered, where did this thing come from? I know I've faced this challenge, and many of our modelers have faced this challenge as well. It's kind of like coming across in this cartoon, coming across these 3 bottles with mysterious liquids, and wondering what we can do with those liquids. It's not until you know what's labeled in them that you can understand what's in them, what I can do with it, or what I shouldn't do with it. But fundamentally, metadata provenance, data provenance is about metadata, and that's critical in understanding the provenance of where data sets come from. They could include things like dataset descriptions, file checksums, documentation of processes, methodologies, and assumptions. So it's really critical that we have that data provenance information, and that really engenders the trust and verifiability of what we're using in terms of our inputs into our models, as well as using that through the system as well. Just a quote definition from the W3C about what provenance is. It's the sources of information, entities, processes involved in producing and delivering an artifact. ARDC also has a very helpful resource there, so I put a link to a page that they host. So check that out if you want to know more and dig deeper. But yeah, imagine you come across this data set. It's an output data set. And wouldn't it be wonderful if you knew all of the things that went into producing the data? So that's what we're really after in data provenance, understanding the components, the entities, as well as the processes such as modeling that went into producing this output data set. And often output data sets from a modeling or simulation activity is used to support decisions. And then subsequently actions can be taken. So transparency and information about all the things that led to producing this data and then led to the decisions and led to the action is a really critical thing to provide rigor to the decision-making process. We can't influence what decisions are made, but if we can inform them, that's making the decision, credible and transparent. It also provides the explainability of those actions that we took. So hopefully through credible data, processes, activities, we can support those decisions to be more transparent, credible, and acceptable. So, okay, so in RAP, Reef Restoration and Adaptation Program, I'm part of the Modeling and Decision Support sub-program, and the premise of the project is that there's the consensus that the long-term survival of the Great Barrier Reef is under threat from climate change. So interventions are necessary for reef restoration efforts in the Great Barrier Reef. So the focus is on generating quality decisions and the need for decision support, credibility in those decisions, right? So the MNDS group is responsible for modeling and producing data to support the stakeholders, the decision makers, and analysts understand what actions can be taken on the reef. So they produce data or knowledge through that modeling, support the stakeholders to make decisions, and then actions could be, for example, should we implement fogging on the reef to insulate from climate change, hot weather? Should we develop genetically modified corals? Should we, intervene through the rubble stabilization efforts? So, are these going to be credible, acceptable interventions on the reef, and can we prove it through modeling and simulation and support that investment? And these are like millions of dollars of investments, so we want some assurance about those interventions. So you can check that out at our website there, or scan that in the QR code if you want to know more about the project. I'll just move on to another project, which is the National Bushfire Intelligence Capability, and that's run out of CSIRO. And similarly, bushfires, as you know, devastating bushfires in previous years, and there's been increased risk of bushfires as we experience changing climates. So this project's about producing data, information, and knowledge through modeling, using the best available information through the inputs and science to produce things like bushfire risk severity and bushfire weather forecasts for upcoming seasons and future seasons, even projected 50, 100 years. So that helps stakeholders make decisions and take action. And these are some examples. So insurance companies need improved bushfire risk data to calculate their levies more accurately. Fire agencies need to need that improved information to help bushfire preparedness. Planning authorities determine where the zoning of where buildings can go, and in peri-urban environments, that's an important input into their decisions and actions. And infrastructure managers take all sorts of risk information, such as bushfires, into consideration when they build publicly funded roads. So no point if we build a road or some infrastructure if it's going to be at high risk of bushfires 10 years down the track, when a road is a 100-year investment, for example. So yeah, some critical, I guess, importance for data provenance. But just taking a peek into what modeling looks like in one of these projects in NBIC. Here I've got a sort of data flow map. Yellows are the data sets, the greens are the data products, and then we've got boxes around the different kind of modeling that happens in the project. And so it's a really complicated process. In NBIG, these involve a series of smaller but chain modeling steps, and data provenance capability is essential in helping the team communicate across the workflow and capture metadata as it goes through the workflow, right? So if you think about current provenance solutions, like tracking these in CSV files or log files, or relying on the knowledge of individual modelers, that sort of works when it's a small project. But when you get to a scale like this, and as the project aspires to ingest finer grained and varied input data sources, and as the team grows out, this sort of gets a bit trickier. Just give you some numbers about the projects. So in RAP MNDS, it's 7 organizations, 5 modeling teams, 35 people all up, with 25 modelers. Imagine getting all of them in one room and trying to run a project. It's pretty complex, from different backgrounds. And so we've got a heterogeneous set of programming languages that are used, whole different range of data formats, and compared with NBIC, it's a bit more homogeneous. At least it's in one organization, but there's still 14 modelers across 7 sub-teams. At least the modeling approaches are a little bit more, I guess, aligned, with a clear sort of pipeline of data products coming out. So, but the motivations for each project in terms of data provenance is different. For example, RAP's about credibility and transparency, and then NBIC's more about data quality and understanding dependency so we can fix stuff when things break. And yeah, so maybe just think about, okay, so why don't we just use existing solutions or approaches that we've done in the past? So one of them is, let's just name our files better. So can we just embed more metadata into our file names? So that's one approach. I give that a 1 star out of 5. Why don't we just write more documentation? So surely people can just write more documentation, and we can just ingest that and read that and understand that fully. So that doesn't really work in practice. It's 1 out of 5, I would say. Why don't we just record everything in a spreadsheet, right? So let's get all the fields that we want and just record it in a spreadsheet, and we'll record all provenance. You'd find that you're going to get multiple sheets, and then different spreadsheets, and then what if you go across different teams? Can you share that formalism, right? So it doesn't really scale there. I've seen one approach where everyone who produces data outputs, so let's just make copies of all the inputs and all the code and everything, put it all into the data output. So everything is self-described. and also the data inputs are in with the data outputs. So it's getting a bit better. I guess the idea is that you can see what was used and what was done, but then your data set's going to get really big really quickly as you generate versions of it. We can use a workflow engine, and that's really good as well. However, it's sort of isolated within the system itself, so you can't really share between these things unless you've got a way of harmonizing the language of the workflow descriptions. You still haven't solved the data management problem either. So, we can try to embed provenance metadata in our data set, and that's an approach that people have done as well. So if we can describe it, if you've got a language for it, we can possibly encode it inside the data set. We still got problems because how do we refer to different data sets and elements in the data set? So we haven't quite solved all the problems. So just taking a step back, so what are the problems, right? So firstly, it's about breaking it into some challenges. So firstly, it's registering and accessing data. So fundamentally, we need to have the data set somewhere and access it. We need to be able to describe the data and its provenance. We need to be able to find and query information. We need to be able to share that all of this information with the right people at the right time, or the right systems as well. And crucially for modeling and simulation projects, we need to integrate that into their workflow. These are sort of the 5 challenges, and I'll come to a generalized, possibly a high-level design of a solution. So this is not implementation specific. So it could look something like this, where we have two components. One is a data registry and one is a provenance registry, where you'd be able to register data sets and facilitate its access. And through the registration, you would be able to describe the data. So you need some kind of language to describe the data sets, right? So we can adopt various metadata schemes and whatnot, but that's fairly well known. And then we can find and access data sets through that registry. And through the registration process, there's also a minting of its identity. So let's consider that as one thing. The other thing is we want to record details of the modeling activity. So model runs, the activities, what the process included, the steps, the entities as inputs and the entities as outputs, who did it, when they did it, and where's the software and such things. So that's what I guess the provenance registry would capture, that aspect, and then we can query its provenance as well. So, and then wrapped around this is an API, so we can access that via human readable sort of means via the web or through systems, machine to machine. So yeah, I guess that's the general high-level solution. And I'll come now to what PROVENA does. PROVENA is a cloud-based provenance management system for projects, and we aim to implement that general architecture. We capture the provenance. We enable people to capture the provenance of data sets and details of the modeling and simulation workflows. And it's currently an AWS-based solution. That's just an implementation specific to choice that we made. But yeah, I'll dive into. You can check out our website, but I'll dive into the high-level features and sort of describe them. So we've got a scalable registry which records data sets, modeling activities, and related metadata. So initially we started with a data registry and a provenance registry, but now we've sort of merged them into the one thing, because essentially it's a registry of all the things in our provenance graph. And the records are queryable via graph database. So So we put stuff in, and we can query them out through various means. And everything that we put into the registry mints a persistent identifier. So it's not just the data set, it's also things like the model software, the model run activities, the people, the organizations, every part of the provenance chain. Anything that is a atomic bit of the graph gets a persistent identifier. And we're using Handle, and thank you ARDC for providing that Handle service. I've been using that as part of our deployments. And because we're using AWS, we get the benefit of a scalable data storage backend, should you choose to use that mechanism. And we've integrated that within the PROVENA access authentication system. So it's got user-friendly security implementations out of the box. And yeah, you can control who sees the data set, who can access it, who can download it. I guess the other nice things in the system, user logins are using identity providers. And we've also included Australian Access Federation just to allow easy onboarding of Australian researchers and selection of government agencies who've signed up to AAF. We've also got Google and GitHub identity provider integration. It's as I mentioned, we've got APIs, so that's just for all kind of machine-to-machine system interactions. And there's a search engine, and I guess lastly, we've made it open source and ready to use operationally. So the team decided to make it open source so that there would be no barriers for other projects to adopt it, whether it's CSIRO or elsewhere. It's really a tool and a platform to support data and research communities improve the data provenance practices. So, all right. So the main thing that I mentioned earlier was the registry, and registry is really the backbone of our system. We've got different objects like people, organization, data sets, models, model run activities, and it's really critical that each one of those have persistently identified resources. And because it enables the linking of these things together to create provenance records. And we've you can see a screenshot of the provenance graph here. We've extended PROV-O, if you know PROV-O, it's a provenance ontology developed by W3C to enable, and you can see the sort of representation of that on the left here. You can see we've sort of extended it using model simulation sort of language, where our entities, we've subtyped entities from PROV-O to have these things. And we've subtyped activity as well for model runs. And PROV-O being activity-centric, we've sort of centered our provenance representation using I guess the model run as the main activity that joins all of these entities and agents in a record. So, for example, if I were to use that in a concrete example, we've got a BriefMod model. The model run uses that software model, and it uses some input data and generates a counterfactual result data set, and that was associated with Bob, who's at UQ. So, so then we can chain these model runs. So if someone used the counterfactual in their model runs, then we can chain that in our graph, right? So that's sort of how it works. Partnering with modeling teams. So this is how they generally do their work. So they would get a data set, run it through their model, produce an output data set. So we wanted to allow people to register and update dataset records as either as they were running it or after the fact, but this would be how they would do it. They would do it either via the web or by API to register and update those records, and then other people can come in and look up provenance information. So that's I guess just a workflow of how you would use Provena. Some screenshots now. So this is the registered data sets in RAP, MNDS. So you can see just standard data catalog view. This is our registry. So these are all the items that are registered in our system. So you can see all the different things. We've got data sets, we've got model runs, and everything else. I'll quickly show a screen grab of me going through the system and querying things. So I've gone in to one of the elements, the model itself, and then clicking on the blue circle there, that's a representation of a model, ReefMod 6.8 GPR. You can see in this provenance visualization that I'm able to do things like query upstream and downstream elements. So you can interactively do that in our system. And this visualization sort of powers the exploration of the graph. The purple circles there are all model runs. So we've used this model in several model runs, and it's produced one data set there. And you can get more information about it. And we can also query things like, show me all the contributing data sets to this output data set. And we can see that was one big data set, the DHW projections from Siemens 6. So yeah. Anyway, keep going. So in terms of data challenges, Provena ticks the boxes in all of those 5 challenges. But in practice, we've provided a system, and you would think that just doing that solves all the challenges, right? Actually, no, because people still have to use the system. So it doesn't solve the problem of registering or describing, querying, all the ings. The system doesn't do that, right? So it's relying on people and people to understand how to use the system, how to describe the data, doing it, and also tools to get information out. So, we were very proud in our team, and built the system, and we thought, having Provena there, people would just go in and register every bit of their data provenance, all the time. I mean, why wouldn't you? Yeah. But actually, if you ask modelers, please register your provenance as you're doing it, or you've done your modeling, please register your provenance. This not really top of their priorities. So that's still a challenge, a social challenge to, I guess, incentivize registering data provenance, but also enable them through tools. So in the next few slides, we've worked really hard to build tools and mechanisms that help our users onboard easily. So thinking about the tools that they're already interacting with, be it via the web, through CSV workflows, through Python clients if they use Python. We've really developed mechanisms for people to get things into the system, and I think the majority of people use this actually CSV workflow that we have to input model runs and then register data sets using the web. We're starting to see people in NBIC interested in using the Python client to automate the registration of things from model runs. But and here's a screen grab of registering a model run using CSV upload. So we've got just fields where we've generated a template of CSV template, and there's a mechanism where you can download the template, fill out the details using various IDs and text values, and then upload it back into the system. Ideally, we'd like to push people towards using client libraries to do that. So you can see here building a provenance payload using Python environment to capture all the relevant dataset information. And we can do that for model runs and other things as well. So it's not just about getting things in the system, it's also trying to get stuff out of the system that's of value. So here we're showing that we can generate a report based on the inputs, the model runs, and the output data sets, and generate a Word document that we can share with our funders and stakeholders, which captures what we did in our modeling activities. So that's really useful as a sort of paper trail of what the program did. And for NBIC, one thing that we're working on is a export to data specification sheet. So once you get all your metadata in, can we generate a ISO 19135 style metadata specification sheet automatically from everything that's in the system? So just trying to get value out of the inputs that the effort that we go into putting the stuff into the system. Speaking of Python, we can also integrate PROVENA client libraries and the data we capture using linked data Python libraries. So we can serialize out to things like RDF Turtle if we want to, or PROVEN, and then merge that with other RDF graphs if that's what you want to do, and also do things like graph visualization using linked data Python libraries. Anyway, just coming to the end now. So we've been working in this space in RAP since 2022, and MBIG since the start of the year. And we've got various numbers of registered items there, you can see there. But I guess just offer 3 reflections. PROVENA is a tool. It won't solve all your data provenance challenges, but in using it, I think teams can have more rigor in their science. It can facilitate conversations that you otherwise would not have around how do you capture data? How do you describe your processes? But I think the challenge is making it easy for our target audience, the modelers, to adopt it. So a big challenge in this space is building tools that our users can easily use and making that easy as possible. And I guess it's not getting too much deep into the jargon of how do you model provenance, right? It's about the doing of it. I really appreciated partnering with projects as the data is produced. It's really opened up interesting conversations about data reproducibility. Even this idea of fundamentally registering a data set with an ID, linking it to what they did, and chaining that through the workflow. I think that was, I guess, the desire that modelers do have, is just enabling them through the tools. Anyway, so to summarize, PROVENA, it's a cloud-based provenance system designed to support modeling and simulation. It's really enabling users to do what would be considered the basics, minting identifiers, capturing information about the entities and processes, and supporting the use of provenance information for their projects and for their, I guess, stakeholders. We think it's general purpose and adaptable to different domains. So if you're interested, we can have a chat and see how that could be relevant for you. We think we give it a 4.5 stars. I wouldn't say that it's a silver bullet for data provenance, but we're working really hard for it to be sort of a way that you can capture the whole pipeline for modeling and simulation data provenance. All right, I'll just stop there and thank you for your attention.